This is Jeremy. We are going for all humanity. Artemis II crew is go for launch. Full send.
4 astronauts just launched into an environment that NASA's own studies say kills people decades after they come home. The Artemis II crew are right now beyond Earth's magnetic field, inside a capsule with the radiation shielding equivalent of a few centimeters of aluminum and water. They are the first human beings to leave low Earth orbit in over half a century, and they are doing it during the most active solar maximum in more than 20 years. Every astronaut who flew to the moon during Apollo reported the same thing during the trans-lunar coast. Bright white flashes behind their closed eyelids, streaks and pinpoints of light that appeared in total darkness. These flashes were individual cosmic ray particles passing through the hull of the spacecraft. The particles did not stop there, as they were also passing through the astronauts' skulls and through the fluid of their retinas, triggering the photoreceptor cells on impact. The astronauts were watching radiation damage their own body in real time. In August of 1972, between the return of Apollo 16 and the launch of Apollo 17, a solar storm tore away from the surface of the Sun at 4 million miles per hour. When it hit Earth's magnetic field 15 hours later, it carried enough energy to detonate over 4,000 American naval mines anchored off the coast of North Vietnam. Mines designed to survive the ocean floor detonated because the sky changed. If any Apollo crew had been in transit or on the lunar surface during that event, NASA's own estimates put the radiation dose at roughly 400 rem in a matter of hours. That is enough to cause acute radiation sickness and potentially kill a healthy adult within weeks. No crew was out there when it hit. That was not engineering. That was the calendar. The Artemis II astronauts are flying through that same unshielded space right now. And the radiation they face is the one problem NASA has spent 50 years studying and has never solved. To understand why NASA's own planning documents use the word showstopper for deep space radiation, you need to understand what Earth's magnetosphere is actually doing for you right now. Sitting wherever you are, your body is absorbing roughly 0.6 millisieverts of cosmic radiation per year. You do not notice because tens of thousands of miles above your head, the magnetosphere is deflecting the vast majority of charged particles before they ever reach your cells. It is a massive, shifting magnetic structure that absorbs and redirects almost everything the sun produces, along with the heavier particles that come from far outside the solar system. The moment a spacecraft crosses past that boundary, the protection drops to zero. In low Earth orbit, astronauts aboard the International Space Station absorb about 150 millisieverts per year, roughly the equivalent of receiving 150 chest X-rays. Beyond the magnetosphere, the radiation splits into 2 types, and both are significantly worse than the public conversation around Artemis acknowledges. The first is solar particle events. These are sudden bursts of protons and heavier ions launched by solar flares, the same kind of event that nearly killed a non-existent Apollo crew in 1972. When a large one hits, the radiation dose outside the magnetosphere can spike from baseline to hundreds of millisieverts in minutes. Current space weather forecasting is so underdeveloped that NASA's own researchers have compared it to where terrestrial weather predictions stood decades ago. The second type is worse because you cannot hide from it. Galactic cosmic rays are high-energy particles that originate from supernovae and other violent events scattered across the galaxy. They travel at close to the speed of light, and the heaviest ones, iron nuclei, carbon, oxygen, carry so much kinetic energy that they pass through spacecraft walls and human tissue without meaningful resistance. When one of these heavy ions silently strikes a strand of DNA, it does not nick it the way a diagnostic X-ray might. It shatters both strands of the double helix simultaneously in what radiobiologists call a complex cluster lesion. The cell's repair machinery cannot fix the break because there is no intact template left to work from. You would expect that adding more shielding solves the problem. The opposite is true. When a heavy ion hits dense material, the impact generates a spray of secondary particles, neutrons, protons, lighter ions, that scatter outward into surrounding tissue and cause more biological damage than the original particle would have caused on its own. More metal between you and the galaxy can mean a higher radiation dose, not a lower one. If you're finding this valuable, liking, commenting, and subscribing is the single best way to support this channel. It helps us to make more videos like these. So, what is actually standing between the Artemis II crew and this radiation environment right now? The Orion capsule uses a layered shielding design. The hull provides baseline protection. The service module, onboard equipment, and storage containers create additional mass between the crew and incoming particles. For solar particle events specifically, the crew has one additional countermeasure that NASA refers to as a storm shelter. That word makes it sound like a reinforced compartment. It is not. When a solar particle event warning comes in, the 4 crew members have approximately 30 minutes to physically rearrange stowage bags, equipment cases, and supply containers into a configuration around their seats that adds several centimeters of extra material between their bodies and the incoming radiation. They are building a barricade out of their own cargo while a particle storm approaches at 1,000,000 miles per hour. Currently available for spaceflight, the vest changes almost nothing. The constant daily bombardment of heavy particles passes through the vest, the same way it passes through the hull. The crew knows all of this. Each of the 4 astronauts is wearing a personal radiation dosimeter that tracks their cumulative exposure in real time. These are the first human beings to carry individual dose monitoring beyond low Earth orbit in the history of spaceflight. When they return, those 4 small devices will hold the most detailed record of deep space radiation exposure ever collected from inside a crewed cabin. That data is the actual payload of this mission. The capsule is the test vehicle, and the crew are the instruments. There is a data set that NASA has been quietly building for more than 50 years, and it tells a story that does not fit cleanly into the Artemis celebration. In 2016, researchers at Florida State University published a study in Scientific Reports examining the mortality records of every Apollo astronaut who flew between 1968 and 1972. Apollo lunar astronauts showed a cardiovascular disease mortality rate roughly 4 to 5 times higher than astronauts who never left low Earth orbit, and 4 to 5 times higher than astronauts who never flew at all. Only 24 human beings have ever left the magnetosphere, which makes the sample size small, but the pattern held consistently enough that the researchers identified deep space radiation exposure as the most probable cause. Michael Delp, the lead author, described the mechanism directly. The radiation beyond Earth's magnetic field appears to damage the cells that line blood vessel walls in ways the body does not repair on its own. The damage builds silently. It does not produce symptoms during the mission or in the months that follow. It surfaces years or decades later as cardiovascular disease that looks like aging, but arrived too early and too aggressively to be coincidence. The Apollo astronauts did not get sick in space. They got sick afterward, and the ones who flew through deep space got sick at rates way higher than the astronauts who stayed in low orbit. NASA funded follow-up research. Their own human research program lists space radiation as a top-tier risk for every mission beyond low Earth orbit, and the internal language is sharper than anything that makes it into the press briefings. In planning documents for lunar surface missions and eventual Mars transits, radiation is described as the single greatest threat to crew health on long-duration flights. Not micrometeorite strikes or mechanical failure. Radiation. And that is the piece of the Artemis II story that vanishes in the launch footage and the crew biography segments. This 10-day flight is not where the real risk lives. 10 days of deep space exposure will increase the chances to the crew's lifetime cancer probability and cardiovascular risk. but it will likely not produce acute symptoms they can feel. The danger is what this mission is supposed to prove for what comes next. If Artemis II demonstrates that a crew can operate in the lunar radiation environment and return within acceptable dose limits, it clears the path for Artemis III, IV, and eventually the months-long gateway station rotations that are meant to prepare humans for Mars. A Mars transit crew would spend roughly 9 months inside the same radiation field that the Artemis II astronauts are crossing in a week and a half. 9 months of galactic cosmic rays passing through the hull every second, with no magnetosphere overhead, and shielding technology that has not fundamentally changed since the aluminum walls that carried Apollo 11. Reed Wiseman, the Artemis II mission commander, has spoken publicly about the radiation risk. The crew were fully briefed on the dosimetry projections, the cardiovascular mortality data, and the limitations of every shielding system currently available. But even with this knowledge, they still volunteered. There is an image from the Artemis I mission that almost nobody talks about. It was captured by a camera on one of Orion's solar arrays during the trans-lunar coast. The capsule sits small and metallic against an empty black background. No Earth visible, no moon in frame. What the photograph cannot show is what was happening at the moment it was taken. Galactic, cosmic rays that had been traveling across the galaxy for millions of years were passing through the hull, through the mannequins and their 5,000 sensors, through every wire and oxygen tank aboard, without stopping. Whatever those dosimeters recorded when the crew returns will define the radiation limits for every deep space mission that follows. Every crew selection for Mars, every calculation about how long a human body can survive outside the magnetic field that made our entire species possible. 52 years ago, a solar storm missed Apollo by 4 months, and nobody outside the agency talked about what would have happened if it had not missed. The Artemis II crew does not have the luxury of that silence. They know exactly what is passing through their bodies right now, and they launched anyway, carrying the instruments that will tell the rest of us what it cost.